All right, so the first section is simplifying radicals with negative radicands. A radicand, if you don't know what that word means, it's the number underneath the radical symbol. But for these questions, just remember, you can basically pull out your negative. So this is really the square root of 98 times the square root of -1. So that's going to just be an I. But we need to do a factor tree. So you need to like think of two numbers that multiply to 98, and you can use a calculator to start dividing, but like 2 and 49 would work. 2 you can't break down because you don't want to do like 1 in itself. 49 would be 7 and 7. So since it's a square root, you're looking for pairs. So we have a pair of 7, so that goes, you pull 1 to the outside. Basically, the square root of 49 is 7. And then we have a 2 left over. So it'd be 7 square root of 2, and then don't forget to put your I because of that negative. So this is what I would type in here. You would do 7 square root. You can press that button right there to do a square root. Make sure your cursor's outside. The I should be like outside your radical. That makes sense. According to these examples. So I'll post these. I won't be able to post them until after class though, because the Zoom won't give me the video until after. So like I said though, with these, you want to basically just pull out your negative. So the square root of negative 192 is really the square root of positive 192 times the square root of -1, which this is just I. And then we have to do a factor tree for 192. So it's even, so I know 2 goes into it. I mean, unless you see something like bigger, sometimes it might be nicer, but 192 divided by 2 would be, what would that be, 91? No, that's not right, is it? No, it would be 96, right? Let me just put that in my calculator. I don't want to embarrass myself. It'd be wrong, so 192.
That's right.
Okay, good. Okay, because I didn't want to like be wrong. And then this we could cut in half. That would be 48. And then you could keep breaking this down. I don't know. That's 12 and 4. That would be 2 and 2. That would be 6 and 2. That would be 3 and 2. And once you break it down, you're not looking at the, so we're not looking at these numbers we broke down. So if you want to cross them out, you can, but we're looking for pairs. So I got a pair of 2s. I got another pair of 2s. I got another pair of 2s. So like each pair you pull one of those numbers out. So that'd be 2 times 2 times 2, or 6. So sorry, I'm kind of running out of space because this one was kind of big, but it'd be 6 I, because the I from the square root of -1. And then the only thing left over, the thing I couldn't make a pair of, was my 3s. So I only had 1, so that stays underneath my root. So it would be 6I square root of 3. And it shouldn't matter. Like the last one I wrote like 6 square root of 3I. It shouldn't matter what order you put those. But just be careful that if you do the I after, it should not be underneath your radical symbol.
Mr. Swope.
Multiply it in. Someone pointed out, yeah, 2 times 2 times 2 is not 6. Sorry, this should have been an 8. So sorry about that. I will try and work with you. So power. So sorry, I was just resuming my recording, but the next section is powers of I. So they might give you something like this where you have to multiply. Remember, when you multiply, oh, I need a screenshot so I can write on this. You add the powers. So this is really I to the 48th. I will show you, I think it was Michaela or Brooklyn, I can't remember. Someone, I was grading one of their things, they showed another way to do it different than I did on the notes. I'll maybe share that. You can also pull out. In the notes I showed you, you want to think how many I squareds you could pull out. So this would really be I squared. You can make 24 I squareds out of 48 because I squared is -1. So -1 to the 24th power. If you plug that in a calculator or just remember, -1 up to an even power is positive. So this would be +1. Oh, so you would click that box. You also could pull out powers of 4. I'll kind of show you a student mentioned a different way that was working for her. So show that way if you'd like, but that's kind of the idea. Like think about how many, like at least for me, one way you could do it is think about how many I squareds you could pull out, um, and then just take it up to that power. If you had like an I left over, then your answer would have an I in it. Like if you had an odd number, for example. So that's the powers of I. Let me know if you have trouble when you get to here. The next sections are dealing with complex numbers. So these were like the notes from yesterday. This section is just adding or subtracting. So just be careful if it's an addition or a subtraction question. But basically just combine your real numbers. So 8 plus -3 would be 5. Then do your imaginary number part. So 7 plus 3i would be 10i. I haven't messed with it, but you should put your answer in this order. I'm not sure if deltamath would mark you wrong though if you did 10i plus 5, but I'm thinking it might actually mark you wrong because they're asking you to put it in that form. So the addition and subtraction shouldn't be too bad. Let me just see, can we get a subtraction one? So if it's subtraction, just be careful. Oops. You either want to rewrite it or just be careful when you're doing it. It would be like 7 minus -12. That would be 19. And then -8 minus 6 would be minus 14i. If it's helpful though, you might want to rewrite it. Like if you're gonna like these one, like you can distribute that minus sign. Like that would turn into a plus 12. That would turn into a minus 6i, and then you could combine them. But it's kind of up to you either way works. But that's adding, subtracting. The section shouldn't hopefully be too bad. The next section you're going to have is multiplying, and this is where you're going to have to FOIL. Oh, this is a good one to see. Oops. So if you see a square, remember, that means you just write your binomial twice. And then you just FOIL. So take your first number, distribute. So that'd be positive 25 minus 50i. Then you're going to take your second number and distribute. So 10i times -5 would be minus 50i as well. And then plus 10i times plus 10i would be, let me just rewrite this so I have enough space. So sorry, it would have been 25 minus 50i minus 50i. And then 10i times 10i would be plus 100i squared. So then you combine your like terms. So be careful, this 100i squared is -1. So that's really like a minus 100. It won't let me write the 0. So 25 minus 100 would be -75. Then minus 50i would just be minus 100i. So if you see a square, you're going to write it twice, but most of these problems I saw, they just give you your two binomials. The last section, which might be kind of tough. Oops, sorry, I wasn't looking at the chat. I'll do that once I do this next one. I'll do some more with the powers. Division, I only put 2 of these because I think this section might be kind of hard, especially the examples. They're all kind of the more complicated ones that we saw in the notes from yesterday. You got to multiply by your conjugate, so that you basically rewrite the same thing as the denominator, but switch it to a plus or a minus, depending on if you had an addition or a subtraction. But basically, we got to multiply these together. So the top, so this is just like what we did on the last problem. You would FOIL, so you'd have -36. 9 times 3i would be 27i. Distribute the 13i, that would be minus 52i. And then 13i times 3i would be plus 39i squared. And if you kind of want to convert that in your head, that's going to be like a minus 39, if you're getting better with that. For the conjugate, when you multiply the bottom, you're going to see that you get positive 16 minus 12i, -3 times -4, -3i times -4 would be plus 12i. -3i times positive 3i would be minus 9i. squared. So we just kind of want to clean this up. But you're going to notice on the conjugate, your i's always cancel out. So the top, though, like I said, oops, this plus 39i squared is really a minus 39 based since I squared is -1. So you're going to have -36 minus 39. That would be -75. Yeah, okay. And then combine your i's, 27 minus 52 would be 325 plus 25i or minus 25i. Oops. And then on the bottom, like I said, remember this minus 9i squared, that's I squared is -1, so that really turns into a plus 9. So 16 plus 9 would be 25. The only issue is I don't know if they need, it does say the simplest form. You could, since all of these terms are divisible by 25, you could simplify this to be -3 minus 1i over 1. So try your best with this section. If it's too much, I'll take it out, but this is what they had for division.